This is Unit 7, Day 3. All right, creating polynomial equations. So there's some key terms here that you guys have to pay attention to. So this first example says, determine the equation. So when you see that, you know you're going to have some form of y equals of the quadratic function whose roots are, so remember, its x-intercepts are at -3 and at +4, which passes through the point to -50. So remember, every point represents an x and a y. Now, if it has roots that are -3 and +4, that means its factored binomial is going to be x plus 3 and x minus 4. Okay? So you're going to set it up in this form every time. Y equals a. A is just your leading coefficient of the standard form of a quadratic equation. So now you're just going to FOIL. So you're going to take x plus 3 times the quantity x minus 4 and you're going to FOIL it. Okay? Or use your box method. So you're going to end up with a times the trinomial x squared minus x minus 12. All right, once you get everything multiplied out over here with the binomials for the factors, you're then going to substitute in the value for x and y. So if x is 2 and y is -50, just substitute in those values and solve for a. So I'm going to get -50 equals a times, and again, substituting in a 2 for all x's. Now don't forget, if x is a negative number, you do have to remember to use parentheses in there. Okay, so I'm going to put a little note that I'm going to solve for a. Alright, so I would use like the store key or something like that. You don't have to do all that by hand, but you end up getting -50 is equal to a times -10. So all of this in parentheses simplified to -10. To get a by itself, you're going to divide both sides by a -10. And don't forget, a negative divided by a negative is a positive, so you're going to get +5. When a is equal to +5, you're going to go back to this step right here, and you're going to substitute a's value in. So now if a's value is 5, you're going to get y equals 5 times the trinomial x squared minus x minus 12. Now just distribute that to all of those, and you're going to end up with 5x squared minus 5x minus 60. This is the equation of the line that has roots at -3 and +4 and passes through the point to -50. Okay, so the second half of this told you to verify your answer by creating a sketch of your function. All right, so now just something to keep in mind. We know that the zeros, the x-intercepts, were at -3 and +4. The y-intercept, what I did, I took the equation that I found, and once I inserted that on a graph page, then I went to the table of values, Control-T, and remember the y-intercept is where x is 0. So look at your table of values where x is 0 and y was -60, or you could substitute back into that equation. All right, it has a minimum. Remember, it's a quadratic, okay, so it's opening up. It has a minimum at 0.5, -61.25. And that's by using Analyze Graph. We did that the whole lesson the day before. So now when I actually graph that, here's one of my zeros, another 0. My minimum is at a half, and then down. Now remember, this is -50, so there's -50. That would be 60, 70, 80, 90. So it's at like 61. So it's going to be somewhere right around here. Oops, it always pops up there. So there's my minimum. Okay, and don't forget, y-intercept at -60. So now I have the quadratic that looks like this. And again, it's more of an accurate drawing there. So there's my y equals 5x squared minus 5x minus 60. Okay? Moving on to example 16. It says it's important to understand how the value affects the graph of the polynomial. This is easiest to explore if the polynomial remains in factor form. You should see from the next example the value of a does not change the zeros of the function, but it's a vertical stretch. Okay? So what this means is all the zeros stay the same, your minimum just changes. Okay, what are the x-intercepts? Now, if you go back and look at this last example, these were the x-intercepts. These were the roots. So what you have in your factored binomial form represented your roots. So now when I come back to this question, okay, this is telling us right here, those are my roots in factored form. So x is going to be equal to -2 and x is equal to +5. So I just factor this, okay? I just did a FOIL, all right? So that ends up having a minimum. So what I did was I put in x squared. Now don't forget, that's really x squared minus 3x minus 10, and that had a minimum of 1.5 and -12.3. Okay? You can also put this right in your graphing calculator as well. You don't have to actually FOIL it out into a trinomial. Okay? But these right here are going to cause stretches. Okay? The bigger the number, the more it gets narrow. So this one has a minimum of 1.5, -25. And the last one has a minimum of 1.5. You can see the x is not changing, only the y's are, -50. So now when I go to graph these, my original graph here, okay, my x squared minus 3x minus 10, or this one, x plus 2 times the quantity x minus 5. Okay, don't forget, it has zeros at -2 and +5. Those will never, ever, ever, ever change. Okay, just your minimums are going to be changing. So at 1.5, there's 1.5 right there, I have to be down at -12.3. So this would be 25. Okay, this would be 12.5. So it's going to be a little less than that right here. Okay, so here's my first graph. My first graph is going to look like a quadratic that does like this. Okay, so this is y equals x plus 2 times the quantity x minus 5. Now if I switch up colors, having a vertical stretch by 2 just makes it narrow a little bit. Okay, so that one has a minimum at 1.5, -25. But again, it's still passing through the same zeros. So that is y equals 2 times the quantity x plus 2 times x minus 5. And the last one has a minimum at 1.5 -50, and it makes it close in even more. Again, still passing through those zeros, just closing up more. And again, guys, how do I know all those minimums? I put the entire functions right on the graph page and then analyze the graph. Okay? All right, example 17. Create an equation of the cubic in standard form, which has x-intercepts. Okay, so it has x-intercepts. So same thing, just what we did in example 15. So I get y equals a, and then don't forget, guys, these are the x-intercepts, the zeros, so now you have to switch and have the opposite signs for the factored form. So it's going to be x plus 4 times x minus 2 times x minus 5. So the first thing I'm going to do is just multiply 2 of them together by FOILing. Okay? So I'm going to get y equals a, and when I FOIL that, I get the trinomial x squared plus 2x minus 8. But then that still has to be multiplied times the quantity x minus 5. Now, how do I do that? Okay, I'll show you and then I'm going to erase it. I have to distribute this x to all of those right there. Okay, so I have to multiply this by x, this by x, this by x. When I'm done multiplying all of those by x, I have to multiply this by -5, this by -5, and that by -5. And then I got to clean it up and combine like terms. Okay? So, y equals a times the quantity. And when I multiply everything times x first, I get x cubed plus 2x squared minus 8x. Now multiply everything by -5. -5x squared minus 10x plus 40. Okay? Combine like terms, clean that all up, and I end up with x cubed minus 3x squared minus 18x plus 40. Okay, that's all cleaned up, combining like terms, all of that's done. Now, don't forget, it tells me that I have this point. 6 is going to get substituted in for x, and 20 is going to get substituted in for y. Okay, so all of these x values right here, every single one of those x values has to get replaced with 6's. Okay, and then the y value over here has to get replaced with a 20. So I end up getting 20 equals a times, and then use your calculator or use the store key, evaluate all the x's at 6, and you end up with 40. To get a by itself, you're going to divide both sides by 40, and you're going to get 1/2 equals a. Now that a is 1/2, you're going to come back to this step right here, and you're going to distribute a half because a is a half. Okay, so you're going to multiply this by a half, this by a half, this by a half, this by a half. So I end up with the equation y equals 1/2 x cubed minus 3/2, do not change them to a decimal, leave them as a fraction, x squared minus 9x plus 20. Okay, from there it says verify your answer by sketching the cubic graph on the axes below. Now you already knew your zeros, so you're at -4, you're at +2, and +5. Those are my zeros, okay? You know it has to pass through the point 620. So now, remember, this is 50. This would be 10, 20, 30, 40. So there's my 20. And you have to be at 620. So, here's 6, here's 20. So the graph goes in that direction. Okay. Now you're going to look for your maxes and your mins and all of that stuff, and you're going to end up with a little sketch that kind of looks like this. Okay. Remember, y-intercept is when x is 0, so if you plug in an x as being 0, you're going to end up at 40. So it's 0, 40. That's where I knew where to put that one. Okay, so this line isn't really great there, but it at least shows the curve. Okay, all right, last example here. Pick up the pace a little bit here. It says create the equation of a cubic in standard form that has a double 0. Guys, that's major. Double 0 means it's tangent, but it also means there's 2 of them. Okay, so that means when you have y equals a, if it's -2, that means you have x plus 2, but there's 2 of them, so it's tangent to that x-axis. And then you also have another 0 at 4, so that's x minus 4. So we're going to go through the same thing. So we're first going to FOIL those, and I end up with y equals a times x squared plus 4x plus 4, and that's going to be times the quantity x minus 4. Okay, now distribute this x to everything and distribute the -4 to everything. That's going to result in x cubed plus 4x squared plus 4x minus 4x squared minus 16x minus 16. Combine like terms and clean that up, and you're going to be left with x cubed minus 12x minus 16. Okay? At this step, now, the hard thing with this one, you have a y-intercept at 16. If it has a y-intercept at 16, that means it's the coordinate 0, 16. So your x is going to have a value of 0. Okay? So you're going to end up with 16 equals a times -16. Divide both sides by -16, and you get a as -1. So then you're going to go back to this equation right here and just switch all of your signs. Your equation is going to be y equals -x cubed plus 12x plus 16, and then you're just going to graph that in the graphing calculator. Okay? I'm not going to graph that, but okay?